Hi, thanks for clicking the video and welcome to my Tech Solutions. In today's video, we will do GRE tunnel configuration, okay, and we will establish a tunnel between the two endpoints, like they will believe like they are connected to each other directly. So, first of all, what is GRE? Okay, the GRE stands for Generic Routing Encapsulation, and it was developed by the Cisco so that different protocol networks can communicate with each other. Okay. Um, by default, it does not provide any data confidentiality and integrity, no encryption at all. Uh, so for the data encryption, it relies on IPsec. You have to combine it with the IPsec so that you can provide the encryption or data integrity, etc. So by default there is no encryption. So without any delay, so let's start configuring it. Okay. I have already done ISP1, ISP2 configuration. IP addresses are already assigned to R1 and R2. All we have to do is assign a default gateway on R1 and R2 so that they can pass traffic to their ISPs and ISP can forward the traffic to the R1 and R2. Okay, and vice versa. Okay. So let's start configuring it. Let me first clear my screen. Now on R1, we'll go under the global configuration mode. Okay, to the terminal IP route. Okay, uh, and this is the for the default route. Okay, dot zero. All zeros means any network. Okay, and after that, all zero means any subnet mask. You pass that to 100.64.1.2. This is my ISP router IP address, and now I have created a default route. Now the same thing I will do on R2. Okay, if you get terminal, do show IP interface brief. Let's verify the IP address assigned to our interfaces and interfaces are up. Now we'll let's create a default route, all zeros, and the destination is 100.64.2.1. Okay, default route is created, and we can verify that by using show IP route, and there is the default route. Okay, S means static, asterisk means candidate default. So this is the default route. Same we can verify on R1 show IP route, and there is also a static route. As for static, asterisk means it is a candidate default. It is a default route. Okay, so let's verify we can if we can ping from R1 to R2 WAN interface. Okay, so let's ping 100.64.2 actually it is 1 because I'm on R2, and yes. Okay, so R2 can reach R1 WAN interface. Let's see if R1 can reach 100.64.2.2 R2 WAN interface. Yes, so we have communication between R1 and R2, but they cannot communicate their LAN segment because currently there is no route. So we will create a tunnel so they can access their local LANs via the GRE tunnel. Okay, so for that what we will do is, and the first thing we will do is go our Google configuration, and from there we will create a tunnel interface. Okay, interface tunnel, and the tunnel number is 1. I will use tunnel number 1, but you can use any. Okay, and interface, then we will use IP address. IP address I will use 192.168.1.1, and with the subnet mask of 255.255.255, and the bandwidth is 4 times 0, and IP MTU is 1400. Okay, and keep alive is 5 seconds, and retry after every 3 seconds. Okay, now tunnel source Okay, from where the tunnel will originate. It will originate from this interface gigabit 0/1. Okay, um, gigabit 0/1. Okay, right. Press enter and tunnel destination. This is the IP address of my R2 WAN interface. So it is tunnel destination, and here I will use an IP address of 100.64.2.2. Let me verify. Show IP interface brief. Yes. Okay, right. Here it is. Then press enter. Now the tunnel is created. Let's create a dynamic routing protocol so that our router can advertise this network to R2. So IP route, sorry, it is router OSPF1. Okay, and enter, and router ID is 1.1.1, and network I will use 192.168.1.0 and 255 in area 0. Okay, and network my local LAN, which is this side in area 1. Okay, so 0.0.255 area 1, right. So configuration is done for the R1 and I have saved it. Now we will do the configuration of R2. So we'll go into global configuration mode. Let's create a tunnel interface tunnel, and tunnel interface number is, you can use any, it doesn't have to match with within the router. Okay, so the interface IP address is IP address 192.168.1.2, and the subnet mask, right. And bandwidth I will use 10 4 times 0, and IP MTU I will reduce it, okay, to 1400, and keep alive is 5 second, and retry is 3 second after 3 second if there is a down. Okay, then tunnel source, and it is gigabit, we'll use it, it is gigabit, and I will use this interface as a source. Okay, on R2, and 0/1. Okay, 0/1, and press enter. Then the tunnel destination IP address I will use R1 WAN interface IP address. Let's verify it. Show IP interface brief, and this is the tunnel destination. Let's copy it and paste it down here and press enter. Now as you can see, the tunnel interface came to up down situation, and now it is up. Now let's create a routing protocol. Router OSPF1, and router ID is, this is 2, so I will use 2, and the network I will use 192.168.1.0 by 255.255. Okay, actually it is wildcard, but you can type in anyway, it will reverse it. It is in area 0, and network is of R2, which is this local LAN 10.2.2.0, 10.2.2.0, and wildcard mask, and I will put it in area 2. Exit, exit. Okay, and as you can see that it has already formed a neighbor with the R1 by using the tunnel 1 interface. Okay, so if I go back and do show interface tunnel 1, I can see that the tunnel is in up and up state, this is the IP address of the tunnel, and the tunnel is sourced from the 100.64.2.2, which is the IP address of this interface, and the tunnel destination is 100.64.1.1, which is the IP address of R1 interface 1. Okay, so the inter-tunnel is up. Let's see if we can. Uh, let's first verify the routing table of R1. Okay, here we can also see that the neighbor agencies are formed between the R1 and R2 via the tunnel interface 1. So show IP route, and I will filter out with the OSPF. Process ID is 1. Okay, so it has formed one inter area route, that is 10.2.2.0 on R1, and this is the R2 local LAN. Okay, and we will verify the same on R2. Show IP route, OSPF, and process ID is 1, and R2 also knows about the local LAN of R1. Okay, now let's do a ping and verify the connectivity. Okay, ping um, 10.2.2.1, and this is the IP address of R2 LAN interface. Okay, so let's do it. If we can do it, yes we can. Let's do a trace route to 10.2.2.1. It will take some time to finish the trace. Alright friends, now R1 forward the traffic to 192.168.2 IP address, and this IP address is R2's tunnel interface IP address. Okay, so this is how we create GRE tunnel. Thanks for watching. If you like, please subscribe and hit like button. Thank you.